Right, so here we have been asked to use vector methods to prove that the diagonals of a rectangle bisect each other. So if I can prove that the bisector of one line and the bisector of another line are the same point, then the point must bisect each other. So the lines must bisect each other. Okay. One way I can do that is to assume that they're different points and then show that they're the same points. Okay. Let's put some arrows in. We've got a rectangle here. I'm going to have vector AD, DC, BC, and AB. And I'm going to have AC, and I'm going to have DB. And now I'm going to pick 2 points that I'm going to define as my midpoints. Now I can see that these are not the midpoints, but my aim is to show that these 2 midpoints are in fact coincident. So they're the same point. And I'm going to have to add an extra vector into here for M2. And obviously for M1 works onto the same vector as AC. All right, let's have a look at how we're going to do this. We've been given that ABCD is a rectangle. Now what that tells us, because of the properties of a rectangle, is that DC equals AB and AD equals BC, and that all of my angles at my vertices are 90 degrees. So what I need to prove is that the diagonals of a rectangle bisect each other. Okay, and here's our proof. So we're going to let this point M1 be the midpoint of AC, and we're going to let M2 be the midpoint of DB. All right. Now, to get from A to M1, well, I know that A to M1 is half of AC. So let's say that AM1 is going to be half of AC because I defined it as such. Okay. And I know that AB equals DC. Because we've got a rectangle. It's one of the properties. So I can relate, I'm trying to relate AC, AM1, AB, and DC to each other. I also know that I can write AB as half AB plus half AB. Bear with me, okay? Because if AB is equal to DC, AB could be written as half AB plus half DC. Okay. Let's make this one equation 1 and this one equation 2. And let's see what we can show. All right. What I might do is carry on here so we can actually see our picture. So what we now have is A to M2, well, I know that A to M2 is going to be AB plus B to M2. So AB plus B to M2. And I know that B to M2 is half of BD. Okay, I've defined it as that. So AB plus half of BD. Okay, I've defined that. Now, I can substitute 2, because AB is half AB plus half DC. Let's call this one 3. So I've got that AM2 is going to be half AB plus half DC plus half BD. All right. And that's going to be, I can take out the halves. AB plus DC plus BD. And where am I going with this? Well, I know that DC plus DB, okay, so DC plus DB will give me BC. Okay, so that's going to be equal to half AB plus BC, and AB plus BC gives me half AC. And that is equal to AM1 from equation 1. Okay, so I've shown those same point. I can say therefore M1 and M2 are the same points and are respectively the midpoints of AC and BD. So therefore the diagonals of a rectangle bisect each other.